All right, let's do negative 1.57 minus 4.2. So the first thing we're going to do, since we're dealing with positive and negative numbers, is to replace the subtraction. So we're going to push that subtraction over. Notice it's not turned into addition, it's still there. We're just, instead of taking away 4.2, we're adding a loss of 4.2. Same thing. So subtraction and adding the opposite are the same thing. If it's easier for you, and for most students it is, we're going to think money. So I can think of negative 1.57 as I owe $1.57. And I can think of negative 4.20 as I owe $4.20. So we're not actually going to subtract at all, are we? So we've got debt, and then we've got more debt. Since both numbers are negative, we're going to combine them. So over here on the side, I'm just going to figure out what is 1.57 and 420. When we add decimal numbers, really important that we line up the decimal. We want to add dollars to dollars, dimes to dimes, pennies to pennies. 7 plus 0 is 7, 5 plus 2 is 7, 1 plus 4 is 5. So the total is 5.77 or $5.77. But keep in mind, these were both negative. This was I owe you, and I owe you. So I don't suddenly have $5.77. I owe $5.77. All right, our next problem is 2.15 minus 9. It's easier to understand what's going on with this problem if we rewrite the problem. We're going to push that minus 9 over and make it a negative 9, and we're going to put a plus sign in front. So I can see that I have $2.15 and I owe $9. Since one number's negative and one number's positive, they're going to eliminate each other. I'm going to use this money to pay off some of my debt. I should be able to see at this point that my answer is going to be negative because I have way more debt than I have money to pay it off. So I know that after I do some elimination, I'm definitely going to get a negative number as my answer. So 9 is the bigger value. So I'm going to put the 9 on top, and I'm going to subtract off 2.15. You have to line up the decimal when you're subtracting decimal numbers, and the 9 doesn't have a decimal. But I know it's $9, so it should be over the $2. We have to line up the decimal. If you want to put in a 0.00, that's such a good idea, then you'll make sure you line up the decimal. And if you're not sure where the decimal goes when it isn't written, just think $9 and you'll get the decimal in the right place every time. So I've got to take 5 pennies away from 0 pennies. I can't do it. So I'm going to look next door and say, hey, any dimes for me to borrow from? There aren't any. So I'm going to look next door again and say, oh, I've got 9 $1 bills right here. So let's cash in one of those $1 bills. I'll have 8 $1 bills left. And I'm going to change that into 10 dimes. 10 dimes is the same as $1. I'm going to put them right here. So I've got 10 dimes to work with now. So now I can borrow from those 10 dimes. I've just got 9 dimes left. And cash that dime into 10 pennies. So now I have enough pennies that I can take that 5 away. 10 minus 5 is 5. 9 dimes minus 1 dime is 8 dimes. $8 bills minus $2 bills is $6 bills altogether. So $6.85, but when I look back, I remember, oh, that's debt, right? That's not money I have, that's money I owe. So that's a negative $6.85. All right, Ben owes his dad $15.75. He earns $25 for walking the neighbor's dog. He spends $22.85 at the movies, and he gets $10 from his aunt. How much money does he have left? So I've got some values in here. I can see I've got the $15.75, but I see that he owes that money. So that's going to be debt. I'm going to think of that as a negative number. He earns $25. $25 earned, that's money in his pocket. So I'm going to think of that as a positive number. He spent some money at the movies, $22.85. When you spend money, that's money you don't have anymore, so I'm going to think of that as a negative number. And then he gets $10 as a gift, so that's money he has. So if I want to write an expression for this, I'm just going to total it all up. Money left, I'm thinking all together, right? All together, if I think of his debt and his earnings, all together, what does he have left? So that's addition. So I'm just going to add them all up. So I'll start with the first number, negative 15.75, debt. I'm going to add the second number, 25, and I'm going to make it into dollars. That's money he's got. And then I've got the third number, that was debt. So $22.85 in debt, so it's a negative number. And then that last number, $10, is money he's got, because he got it from his aunt. So when I add all these up, it's harder to add a positive number to a negative number than it is to add positive numbers and negative numbers. So I'm going to figure out all together how much money did he either have in debt or did he lose. So let's total those up first. So 15.75 combined with 22.85. 5 and 5 is 10. It's 15 plus 1 is 16. 5 and 2 is 7 plus 1 is 8. 2 and 1 is 3. Drop that decimal. So it looks like I have a total loss of $38.60. Let's figure out what the gain is. What's the total gain? So I've got $25 plus $10. Oh, this one's way nicer. So 0, 0, 5, and 3. So I have $35 gain. So he gained 35, he lost or is in debt for 38. So now when I add them together, because one's positive and one's negative, they're going to eliminate each other. I'm going to have to spend this $35 paying off my debt. So I'm going to take that 38.60 and I'm going to subtract off the $35. 0 minus 0 is 0. 6 minus 0 is 6. 8 minus 5 is 3, and 3 minus 3 is 0. Drop your decimal down into your answer, and I have $3.60. But remember, this debt is actually a larger quantity than this money earned or money had. Since the debt is bigger, he doesn't have $3.60. He owes $3.60. So he's going to still owe his dad at the end. He didn't have enough money to pay off his debt. So the answer would be negative $3.60, or you could say he still owes $3.60. All right, multiplying decimal numbers. So now I've got negative 2.75 times 8. When you are multiplying decimal numbers, you do not have to line up the decimal. And the reason is only one of these numbers is money. So I could think of this negative 2.75 as I owe $2.75. And 8 might be I owe it to 8 people, right? It's 8 groups of negative 275. Since this isn't money, there's no reason to line up the decimal. For multiplying decimal numbers, I can multiply first and worry about the decimal point later at the end. So 8 times 5 is 40. 7 times 8 is 56. Plus that 4 is going to be 60. 8 times 2 is 16. And when I add in the 6, I'm going to get 22. So I've done all my multiplication. Now I have to think about the decimal. 2.75 is pretty close to 3, right? If I had $2.75, I'd think, I got about $3. In this case, it's debt. So I owe about $3. 3 times 8 is 24. I'm expecting an answer somewhere around 24. I've got 2 decimal places in my problem. So I'm going to put 2 decimal places in my answer. And my decimal's going to go right there. And that's pretty close to 24, right? This was a little less than 3, so I'm expecting my answer to be a little less than 24. So that feels pretty good to me. So first I multiply, then I deal with the decimal, and last I got to figure out, is my answer positive or negative? Those 8 groups of $2.75 was $2.75 of debt. So you could say I owe 8 people $2.75. So my answer is going to be negative. A negative times a positive is always a negative. So that's your answer right there. All right, so we have negative 1.82 times 0.5. So the first thing we're going to do is just multiply the numbers. So I'm going to stack them up. 5 times 2 is 10. 5 times 8 is 40, plus 1 is 41. 5 times 1 is 5, plus 4 gives me 9. So that's my multiplication. Then I have to deal with the decimal. Well, 1.82 is pretty darn close to 2, right? And 2 times 0.5, 0.5 is like a half. So half of 2 is going to be 1. I'm expecting an answer pretty close to 1. 910 is nowhere near 1, but I haven't put any decimals in. So let's see how many decimals are in the problem. So I've got 2 decimal places in this number, and I've got 1 decimal place in this number. So altogether, that's 1, 2, 3 decimal places. 1, 2, 3 decimal places. So my decimal is actually going to go right here. And 0.91 is pretty close to 1. So I feel pretty comfortable with that. So first we multiplied, then I put my decimal in, then I got to decide whether my answer is positive or negative. If I look up here, it's negative 1.82 times 0.5. A negative times a positive is a negative. So my answer is negative 0.91. Claudia bought 4 mechanical pencils for $2.75 each, and she bought 3 erasers that cost $1.25 each. How much money did she spend? So she bought 2 different types of things, mechanical pencils and erasers. So I know that the money she spent on pencils plus the money she spent on erasers is going to be equal to the total money, right? So if I can figure out how much money she spent on the pencils and then add that to the amount of money she spent on the erasers, I'll have all together how much money she spent. So I know the pencils were $2.75 each, and I know that she bought 4 of them. So 4 mechanical pencils, each one cost $2.75. So the first pencil, $2.75. The second pencil, $2.75. The third pencil, $2.75. I'm using the same number over and over again. So that's 4 groups of $2.75. That's multiplication, right? When we have groups of, that's multiplication. When we're adding the same thing over and over again. So I'm going to have 4 times $2.75. All right, I'm going to add that to the total amount of money she spent on erasers. So it says here that she bought 3 erasers and they cost $1.25 each. So $1.25 for the first eraser, $1.25 for the second eraser, $1.25 for the third eraser. That's 3 groups of $1.25. Still with me? All right, so I got to figure out what this is and what this is, and then I'm going to add them together, and I'll have the total amount of money she spent. So 2.75 times 4. Multiply first, worry about the decimal at the end. 5 times 4 is 20. 7 times 4 is 28, plus 2 is 30. 4 times 2 is 8, plus 3, 8, 9, 10, 11. That's 11. All right, so I have 1,100. That's the first thing I need to do. The second thing, I got to figure out where my decimal goes. Again, this is about $3 times 4, so I'm expecting something close to 12. So I have 2 decimal places in my problem. I'm going to put those 2 decimal places in my answer, and it turns out she spent $11 on pencils. And that's pretty close to 12, so I feel pretty comfortable that that's right. I got $1.25 times 3. 5 times 3 is 15. 2 times 3 is 6, plus 1 is 7. 3 times 1 is 3. So 375, I got 2 decimal places in my problem. I'm going to put 2 decimal places in my answer. And it looks like she spent $3.75 for those 3 erasers. And that seems to make sense. Each eraser is about $1. So if I have 3 of them, I'd expect something around $3, a little bit more. So 3.75. So now that I know how much money she spent on pencils and how much money she spent on erasers, I'm ready to total it up. Now that I'm adding decimals, I have to be very careful to line up the decimal place. So I'm going to put the 3 here in the dollars column. I'm going to put the 7 where the dimes go, and I'm going to put the 5 in the pennies. And I'm going to add them up. 0 plus 5 is 5, 0 plus 7 is 7, 3 plus 1 is 4, 1 plus nothing is 1. So my total is $14.75. Now we are dividing decimal numbers. So I have negative 48.25 divided by negative 5. So I'm going to divide the numbers first, but hopefully you can see that a negative divided by a negative is a positive. So my answer is going to be a positive number, so I'm not going to have to worry about the sign at the end. The first number always goes under the division bar. Doesn't matter if it's the bigger number or the smaller number. The first number always is going to go under the division bar, and then the second number, that goes out front. So I'm going to divide 5 into 48.25, and again, you can think money. This kind of sets up nicely for money. So I'm taking these $48.25, and I'm passing it out to 5 people. I'm trying to figure out how much each person gets. I have 4 $10 bills. That's not going to be enough to give to anyone because I have 5 people, so nobody gets any $10 bills. So now I'm going to cash those $10 bills in and get 48 $1 bills. Those I could pass out. So I could give 9 $1 bills to each person if I had 48 of them. 9 times 5 means I passed out 45 $1 bills. And when I subtract, I see I've got 3 $1 bills left. So I'm going to cash those in for dimes. 3 $1 bills would give me 30 dimes, and I'm going to bring in these 2 dimes. So I've got 32 dimes altogether I'm going to pass out to these 5 people. I could give each person 6 dimes. 6 times 5 is 30, so I passed out 30 of my 32 dimes. So it gives me 2 dimes left over. When I bring down this 5, I'm changing those 2 dimes into pennies. So I've got 20 pennies plus 5 pennies, 25 pennies altogether. If I'm passing 25 pennies out to 5 people, I can give each person 5 pennies. 5 times 5 is 25, so I passed out all of my pennies and I'm done. So my answer is 0965, but that's a huge number, 965. I'm not going to give $965 to each person. I only had $48.25 to start with. So you got to make sure you pop that decimal up into your answer. So our answer is going to be 9.65. And a negative divided by a negative is a positive. Negative 3.51 divided by 0.2. Well, first thing I'm going to notice is that a negative divided by a positive is going to give me a negative answer. So I'm going to put that negative down there ahead of time because I am going to forget to do it later because of all this math. All right, then I'm going to divide. So 3.51 goes under the division bar and 0.2 goes out in front. The problem here is this 0.2. I don't have any way of taking care of that decimal. Remember, I'm going to do my answer and then pop this decimal right up into my answer. And I'm not going to have any way of showing that this was not a 2, this was a 0.2. So we have to get rid of this decimal. And we're going to do it by recognizing that all division problems are the same thing as fractions. So negative 3.51 divided by 0.2 is the same as negative 3.51 over 0.2. These are the same thing. All division problems are fractions. All fractions are division problems. And once you look at it this way, you can see that it would be okay for me to multiply this 0.2 by 10, which would scoot the decimal over, as long as I did the same thing in the numerator. This is just like our equivalent fractions. As long as I multiply the numerator and denominator by the same thing, I'm really only multiplying this fraction by the number 1. And anything times 1 is itself. It doesn't change the number. So here, when you have a decimal out front of the division bar, you're going to scoot that decimal over one place to the right. until you get a whole number. There shouldn't be any decimals out here. And because it took one place to get this decimal out of the way, so I have a whole number, I'm going to match that right here. So instead of 3.51 divided by 0.2, I'm going to have 35.1 divided by just 2. These are the same problem because I moved the decimal the same amount in both of my numbers. So now I can do my long division. 2 goes into 3 once, with 1 left over. Bring down the 5. 2 goes into 15 7 times. 7 times 2 is 14. So I still have 1 left over. Bring down the 1. 2 goes into 11 5 times. 5 times 2 is 10. And I have 1 left over again, and I've run out of digits. So I'm going to put a 0 in there and keep going. Bring the 0 down, and now I've got 10. And 2 goes into 10 5 times. That's nice and even. 5 times 2 is 10. I've got nothing left. So now, because there's no decimal out here, I can just pop that decimal up into my answer. My answer is 17.55. Now we said that a negative divided by a positive is negative. So easy to forget about that negative sign after all that long division. So the final answer is negative 17.55. Sanjay has $2.50. He can buy a carton of milk in the lunchroom for 30 cents. How many cartons of milk can he buy? So he's going to start with his $2.50, and he's going to split it up, right, into groups of 30 cents. So 30 cents for the first carton of milk, 30 cents for the second carton of milk, 30 cents for the third carton of milk, and so on until he's out of money. That's splitting up of a whole into parts. That is division. So we need to divide $2.50 by 30 cents. So I'm going to write the problem 2.50 divided by, be careful here, you have to divide the same units. So you can divide dollars by dollars, you can divide pennies by pennies. I can't divide dollars by cents and get any answer that means anything. So instead of writing 30 cents, I'm going to write 0.30 because that's what 30 cents looks like on a price tag, right? So that's 30 cents in dollars. So now that 2.50, I'm going to put under the division bar, and the 0.30 I'm going to put up front. But I noticed that only the 3 has any value to it. We call that the significant digit. This 0, whether it's here or not, this is still 3/10. It's still the 3 in the 10th spot. So I'm actually going to get rid of that 0 and just use the 0.3 because the math will be easier for me. And when I do that, then I can see I only have to shift this decimal over 1 decimal place to get rid of it. So if I shift it over 1 decimal place to get rid of it out here, I'm going to match that, always match it under the bar. So they should shift over the same amount. So I get 3 divided into 25.0. All right, so this is the problem I need to do. 3 doesn't go into 2, so I'm going to put a 0 up there. 3 does go into 25. It goes into 25 8 times. 8 times 3 is 24. When I subtract, I can see I have $1 left. So I'm going to bring down the 0. 3 goes into 10 3 times. 3 times 3 is 9. And now I've got 1 left over. Let's bring down another 0. 3 goes into 10 3 times. 3 times 3 is 9, and I get a 1 again. So I'm starting to see that I got a pattern here. It looks like it's always going to be 3, right? If I bring down a 0, I'm going to need another 3. So these 3s are repeating 3s. So I'm going to pop this decimal up into my answer, and I know that my answer is going to be 8.3333333 going on forever, ... So we can write that as 8.3 with a bar over it for repeating. Now I could put a box around this and call it my answer, but you got to think about what are they asking us for? How many cartons of milk he can buy? Have any of you ever bought 0.33333 cartons of milk? You never have, and you never will. They don't sell milk that way, right? You either buy a carton of milk or you don't buy the carton of milk. So I am not going to use this part. He doesn't have enough to buy 9 cartons of milk, right? But he has more than he needs to buy 8. So if they ask me how many cartons he can buy, I'm going to say he can buy 8 cartons. He'll have some money left over, but he can only buy 8 cartons. He can't buy 9 cartons, and you can't buy part of a carton of milk.